So let's try to solve a problem involving boundary work. Please read the problem and try to draw a diagram describing the problem and answer these few questions. So we have a piston and cylinder device with the piston held with a spring. At the beginning of the process, the spring is not compressed, so there is no force from the spring on the piston, and we are given the area of the piston, pressure and starting volume, and we are told that the piston cylinder device is heated until the volume is doubled. So the final volume is going to be 0.1 cubic meters and the final pressure is 320 kilopascals. We are asked to plot the process on a PV diagram. So here is my PV diagram, and please note that the horizontal axis is total volume, not the specific volume. So I'm starting my process at 0.05 cubic meters and 200 kilopascals, and I linearly increase my pressure to 320 kilopascal, and the volume is going to be 0.1 cubic meters. The reason why I am increasing this linearly is because the spring is a linear spring. Total work done by gas is given by the area under the process curve. So we can find the area of this trapezoidal area of part 1 plus area of part 2. So it's going to be 13 kilojoules. And the question asks, what is the fraction of this work done against the spring? So the idea is we are working against two forces. One force is atmospheric pressure. So the atmospheric pressure generates a force on the piston. We are working against it, and also the spring works against our push to expand. Atmospheric pressure remains constant throughout the process. Atmospheric pressure remains constant throughout the process, and we are told at the beginning the piston is not exerting any pressure on the piston. So we can safely assume that the atmospheric pressure is 200 kilopascal. Since it is not changing throughout the process, we can say that the done against atmospheric pressure is given by the area 1. On the other hand, work done against the piston is given by area in the region 2. So we can calculate the work against piston. We can calculate the area in region 2 by multiplying 120 into 0.05 and dividing it by 2. So the work done against the piston is 3 kilojoules. Alternatively, we can use this equation to find the work done against the piston.